Am I on the screen?
We're rolling.
Okay.
Well, you're not on the screen, but
London
it's on.
entrance.
Shall I stop it?
Well, I could just do that. How was that?
That was brilliant.
Right. Here, this is the question. And I quite liked this because they didn't tell you what the equation was. So sometimes with transformations, they give you what the equation is, but this is obviously just some kind of made-up, not continuous graph. And so you can't do it algebraically by subbing numbers in and working out what would happen. You actually have to understand the transformations for it. So the first one says, sketch the graph of y equals 2 times f of x from -2 to 4 on the axes provided. They drew out some axes for you, and I think the axes that they drew out actually had the original graph on it, which looked like that. A bit better than that. And so what we've just said is 2 times f of x. That would be a stretch, scale factor 2 in that direction. So everything would be twice as far from the x-axis. So our new graph is going to start at the same point, because that twice as far from 0 is still 0, and it's going to go up as a straight line to 4. That is shocking. And then that bit twice as far up, so that's going to go down to 2, and then that's going to remain twice as far up, so it's going to look like that. That's a straight line there, just in case. Okay, so that would be the first 2 marks. And then part 2, describe the transformation which takes f of x to f of x minus 1. Well, if we just go on those rules that we've just written that f of x plus a is a translation minus a units parallel to the x-axis. So f of x plus minus 1, that would be 1 unit to the right, positive 1 unit in the x direction. So for part 2, if we take f of x and we transform it to f of x minus 1, then the key words that they're looking for here is saying that this is a translation, and it's parallel to the x-axis, and it's plus 1 unit in the positive x direction, parallel to the x-axis. There we go, and that's our 2 marks.
Rock on.